Now it's time to discuss surface areas and volumes of spheres. And we've got two content standards and mathematical practices 1 and 6. Previously, you found surface areas of prisms and cylinders. Now we're going to find surface areas of spheres and volumes of spheres. New vocab: great circle, a pole, and a hemisphere. A radius of a sphere is a segment from the center to a point on the sphere. A chord of a sphere is a segment that connects any 2 points on the sphere. A diameter of a sphere is a chord that contains the center, and then of course the tangent to a sphere is a line that intersects the sphere in exactly 1 point. The surface area of a sphere can be, the formula can be written as 4 times pi times r squared. So we're going to use that formula to define the surface area of this sphere round to the nearest tenth. So 4 times pi times 4.5 squared. Using a calculator, it's approximately equal to 254 and 5/10 square inches. Okay, making a note of that formula, let's check our progress. So pause the video for a moment, then come back and check your answer. 4 times pi times 6 1/4 squared is 499 square inches. Using great circles to find the surface area. So we've got to find the surface area of this hemisphere. It's a half of a sphere. So what we're going to do is take the formula for the sphere, take half of it, plus it has a bottom to it since it's cut in half, so we have to add the area of the circle on the base. The radius is 3 7/10, so approximately equal to 129. Now we're going to find the surface area if the circumference is 10 pi. Well, we know the formula for circumference is 2 pi r. It's equal to 10 pi. We divide both sides by 2 pi, so the radius is 5. Now we go back and substitute in the radius of 5 in to the surface area of a sphere. It's approximately equal to 314 2/10. And then finally, we're going to find the surface area of a sphere if the area of this great circle is approximately 220 square meters. So we're going to find out what the radius is by substituting the formula for the area of a circle, and we know it's equal to 220. Divide both sides by pi and take the square root. It's approximately equal to 8.4. Substitute that in for radius, and it's approximately equal to 886 7/10 square meters. Okay, time for us to check our progress. Again, we're going to have 3 separate ones we're working on. The first thing is we have to find the surface area of this hemisphere. And notice that we've got this circle, so we've got to have its area as well. So I'm taking half of 4 pi r squared plus the area of this base, pi r squared. The radius is 4 2/10, so we substitute in and we get 163 3/10 square meters. Now we're given the circumference of the great circle. We've got to find what the surface area is of the sphere. So pause the video and then come back and check your work. We divide 8 pi by 2 pi r. So divide both sides by 2 pi. The radius is 4. Substituted in the formula. 4 times pi times 4 squared, 201 1/10 square feet. And finally, we're going to have to find the surface area of this sphere. if the area of this great circle is approximately 160 square meters. Pause the video and come back and check your work. So pi r squared is equal to 160. Divide both sides by pi and take the square root. The radius is 7 1/10. Substitute that into 4 pi r squared. And I get a rounding issue close to, I get 633 1/10. So this is the closest answer to it. Key concept, the volume of a sphere is 4/3 times pi r cubed. So we're to find the volume of this sphere, given that the great circle circumference is 30 pi. So again, we need to set 2 pi r equal to 30 pi, divide both sides by 2 pi, that r is 15. Substitute the radius in the formula and use a calculator. Find the volume of this hemisphere, so half of a sphere. The diameter is 6 feet, so we know that the radius is 3. Substitute in, this time we're taking half of that volume. So the volume of the hemisphere is approximately 56 5/10 cubic feet. All right, let's find the volume of this sphere to the nearest tenth. So pause the video, then come back and check your answer. So volume is 4/3 pi r cubed. We're told that the radius is 8. I multiplied 8 cubed is 512 times 3.14159 times 4 divided by 3 for the 4/3. I got 2,144.65, which rounds to 0.7 cubic centimeters. Now we're finding the volume of the hemisphere. So pause the video and work the problem, come back and check your answer. Well, we know this radius is 40. Substituted in, 40 cubed is 64,000 times pi times 4/3 times 1/2. And this is our answer. I got a little rounding issue. I ended up with 134,041.2. So it just depends on if you're using your pi button or 3.14159. It's going to be rounding. Okay, real world example 4. The stone spheres of Costa Rica were made by forming granodiorite boulders into spheres. One of the stone spheres has a volume of about 36,000 pi cubic inches. What is the diameter of the stone sphere? Well, you know what the volume is, and you know the formula for volume. So we can set the given volume equal to the formula for volume. Divide both sides by 4/3 pi. Then take the cubed root of 27. If you're unfamiliar with taking a cubed root, enter in 27,000 in the caret button. You're going to go to the power of 1 divided by 3, or 1/3. When you enter, you get 30. So if this was a fifth root, it'd be to the power of 1/5. You can check your work by putting it back into the, do a backward check for the solution. See if you get 36,000 pi. All right, check your progress. So pause the video, work the problem, then come back and check your answer. We're given that the volume is 4,000 pi, so we're going to set that equal to, is a hemisphere, so 1/2 of 4/3 pi r cubed. Divide both sides by pi, multiply both sides by 2, then multiply both sides by 3/4. I end up with r cubed is equal to 6,000. 6,000 to the power of 1/3 is 18 and 17 hundredths. Times 2 gives us 36 and 3/10. Okay, you're ready to begin working on the assignment.